The launch of the GSLV-F14 INSAT-3DS mission is accomplished on Saturday, February 17, 2024 at 17:30 Hughes IST from SDSC Shah, Sriharikota. In its 16th mission, the GSLV aims at deploying the INSAT-3DS meteorological satellite into the Geosynchronous Transfer Orbit, GTO. Subsequent orbit-raising maneuvers will ensure that the satellite is positioned in a geostationary orbit. Hello, space enthusiasts. Today, we're diving into the GSLV-F14 INSAT-3DS mission, a groundbreaking venture on February 17, 2024. In its 16th mission, GSLV launched from Sriharikota, carrying the INSAT-3DS meteorological satellite, marking a pivotal step in advancing our understanding of Earth's atmosphere and meteorological services. Stay tuned as we unravel GSLV-F14's intricacies, a colossal three-stage launch vehicle weighing 420 tons. From solid propellant to the cryogenic stage, we'll explore how this engineering marvel propels satellites into geostationary orbit, ready for crucial tasks. The star of the show is the INSAT-3DS satellite, funded by the Ministry of Earth Sciences. Designed for enhanced observations, it promises to revolutionize weather forecasting and disaster warning. Indian industries played a key role in its development, contributing to space technology. We'll delve into the mission's primary objectives, from Earth surface monitoring to providing vertical profiles of atmospheric parameters. Explore the satellite's salient features, from payloads to thermal control. There's much to unpack, making this journey exhilarating. So, space enthusiasts, buckle up for a cosmic adventure. Like, subscribe, and hit the bell to stay updated on space news. Without delay, let's launch into the GSLV-F14 INSAT-3DS mission. Ready for liftoff? Let's go. On February 17, 2024, at 17:30 Hz IST, the GSLV-F14 INSAT-3DS mission successfully launched from SDSC Shah, Sriharikota, marking its 16th mission. The GSLV-F14 aimed to deploy the INSAT-3DS meteorological satellite into the Geosynchronous Transfer Orbit, GTO, with subsequent orbit-raising maneuvers planned to position the satellite in a geostationary orbit. GSLV-F14. The Geosynchronous Satellite Launch Vehicle, GSLV, is a 51.7-meter-long, three-stage launch vehicle with a liftoff mass of 420 tons. The first stage, GS1, includes a solid propellant, S139 motor, and 4 Earth-storable propellant stages, L40. The second stage, GS2, and the third stage, GS3, are Earth-storable and cryogenic stages, respectively. GSLV is versatile and capable of launching spacecraft for communication, navigation, Earth resource surveys, and other proprietary missions. INSAT-3DS. The INSAT-3DS satellite, funded by the Ministry of Earth Sciences, MASIH, serves as a third-generation meteorological satellite in geostationary orbit. Designed for enhanced meteorological observations, it contributes to weather forecasting and disaster warning. With significant contributions from Indian industries, INSAT-3DS augments the services provided by operational satellites like INSAT-3D and INSAT-3DR. Mission objectives: 1. Monitor Earth's surface, conduct oceanic observations, and observe the environment in various meteorologically important spectral channels. 2. Provide vertical profiles of various atmospheric meteorological parameters. 3. Offer data collection and data dissemination capabilities from data collection platforms, DCPs. 4. Provide satellite-aided search and rescue services. Satellite salient features: 1. Mission, meteorological services, data relay, and satellite-aided search and rescue services. 2. Payloads: 6-channel imager, 19-channel sounder, data relay transponder, DRT, satellite-aided search and rescue transponder, SAS&R. 3. Orbit, geostationary orbit. 4. Structure, I2K platform. 5. Thermal, 6-channel imager, passive and active thermal control system, biannual yaw flip to reduce thermal load on passive coolers. 6. Power generation, 42. V sunlit regulated single bus, power generation 1505W, Equinox, I2K solar panels, and Li-ion 100A battery for eclipse support. 7. Launch vehicle, GSLV with a 4m diameter, ogive payload fairing with a standard 937-meter diameter interface.
All stations, stand by for the time mark. T-minus 30 minutes and counting.
RNMS to CDP. RNMS confirms range real-time network readiness for GSLV-F14 INSAT-3DS mission launch.
नमस्कार, शुभ संध्या। स्वागत है आप सभी दर्शकों का इस वर्ष के द्वितीय प्रमोशन मिशन में, जिसका नाम है GSLV-F14 INSAT-3DS मिशन। मैं विकास स्वर्णकार आपके सामने हिंदी में कमेंट्री प्रस्तुत कर रहा हूं और मेरे साथ है मिस माधुरी पी, जो इंग्लिश में कमेंट्री प्रस्तुत करेंगी। हमने इस वर्ष का स्वागत 1 जनवरी 2024 को PSLV C58 एक्सपोसैट मिशन के सफल प्रक्षेपण के साथ शुरू किया था और आज हम पुनः तैयार हैं अपने अगले प्रमोशन मिशन के लिए। आज 17 फरवरी 2024 को भारतीय मानक समय के अनुसार शाम 5:35 पर GSLV-F14 रॉकेट का प्रमोशन सतीश धवन अंतरिक्ष केंद्र के द्वितीय प्रमोशन मंच से किया जाएगा। GSLV-F14 रॉकेट द्वारा INSAT-3DS नामक मौसम विज्ञान उपग्रह को भूतुल्यकाली अंतरण कक्षा, जिसे हम जियो सिंक्रोनस ट्रांसफर ऑर्बिट के नाम से जानते हैं, वहां प्रमोचित किया जाएगा। तत्पश्चात सुनियोजित युक्ति चालन से इस उपग्रह को भू स्तर कक्षा में स्थापित किया जाएगा।
Namaste, good evening viewers. Welcome to the live telecast of the launch event of GSLV-F14 INSAT-3DS mission, brought to you from the Mission Control Center at Satish Dhawan Space Centre, Shar, the spaceport of India. The launch is scheduled to take place today, the 17th of February 2024 at 17:35 hours Indian Standard Time. I am Madhuri giving the commentary in English, and with me is my co-commentator Shri Vikas Varnakar giving the commentary in Hindi. This telecast is being brought to you by the courtesy of Doordarshan. Apart from this, the launch can also be watched on ISRO website, YouTube, Facebook and X. The launch will take place from the second launch pad at SDSC Shar. The objective of the launch is to place the weather observation satellite INSAT-3DS, weighing 2,274 kilograms, in geosynchronous transfer orbit, whose perigee is 170 kilometers and apogee is 37,682 kilometers, with an inclination of 19.35 degrees. The satellite is a user-funded project with Ministry of Earth Sciences.
अप्रैल 2001 से शुरू करते हुए अब तक GSLV Mark II के 15 प्रमोशन हो चुके हैं, जिसमें से 11 सफल प्रमोशन रहे हैं। वर्तमान प्रमोशन 16वां प्रमोशन है GSLV Mark II रॉकेट का। पिछला प्रमोशन GSLV-F12 NVS मिशन था, जिसका सफल प्रक्षेपण हमने 29 मई 2023 को देखा था और उसी कड़ी को जारी रखते हुए यह प्रमोशन भी एक महत्वपूर्ण मील का पत्थर साबित होगा।
This is the second launch of the year 2024. Previous launch was held on 1st of January for PSLV C58 ExpoSat mission. Present launch is 16th launch of Geosynchronous Satellite Launch Vehicle GSLV and the 10th flight of indigenous cryostage, including its 3 developmental flights.
अब आपके सामने प्रस्तुत है डेकू द्वारा तैयार किया हुआ एक कर्टेन रेजर वीडियो।
The weather plays a significant role in shaping our daily lives. Severe weather events like floods, cyclones, cloudbursts, landslides, droughts, etc. have the potential to greatly disrupt people's lives due to the extensive damage they inflict. INSAT-3DS is a state-of-the-art meteorological satellite developed by ISRO and will provide continuity of services for INSAT-3D and INSAT-3DR. This satellite is specifically engineered to provide advanced meteorological observations and meticulously monitor both land and ocean surfaces for weather forecasting and disaster warning with state-of-the-art meteorological payloads. It is configured with 4 payloads such as imager, sounder, data relay transponder and satellite-aided search and rescue system. Improvements are carried out in the INSAT-3DS imager and sounder payloads for better meteorological products and increased imaging throughput. INSAT-3DS is designed on ISRO's reliable I2K bus platform with necessary modifications to fulfill the unique demands of the mission. The data from INSAT-3DS satellite will help to predict short-range weather forecasts for extreme events such as heavy rainfall, thunderstorms, fog detection, visibility estimation to help the aviation industry. Additionally, INSAT-3DS will provide information about forest fire, smoke, snow cover, ocean, climate studies, identification of potential fishing zones, etc. The satellite will be placed in a geostationary orbit and the mission life will be around 10 years. The data from INSAT-3DS will be disseminated to the user community through the Multi-Mission Data Receiving and Processing System. The mission INSAT-3DS is fully funded by the Ministry of Earth Sciences. The Geosynchronous Satellite Launch Vehicle GSLV-F14 will launch the satellite from the second launch pad of the Spaceport of India, SDSC Shar, Sriharikota. The vehicle consists of 3 stages. The first stage is made up of 4 liquid strap-on boosters and a solid rocket motor at the core. The second stage of the vehicle is equipped with liquid propellant and the indigenous cryogenic upper stage forms the third and final stage of the vehicle. Additionally, the vehicle's payload fairing features a 4-meter diameter Ojai version. The addition of INSAT-3DS to India's space program will greatly enhance our ability to observe, understand and forecast weather patterns.
That was a curtain raiser regarding GSLV-F14 INSAT-3DS mission. The satellite INSAT-3DS is a meteorological satellite intended to be placed in geostationary orbit, wherefrom it will have a continuous visibility over the Indian subcontinent region. It will be augmenting the meteorological services along with the presently operational INSAT-3D and INSAT-3DR in orbit satellites.
Normalcy of all 4 PSBTs. Copied.
GSLV-F12 के प्रमोशन की उल्टी गिनती 27.5 घंटे पहले पूर्व प्रारंभ हो चुकी है। इस दौरान यान के सभी तंत्रों को पावर ऑन कर सुदूर स्थल से इनकी स्वास्थ्य जांच की जा रही है। क्रमबद्ध तरीके से यान में तरल नोदक की स्थिति प्राप्त कर भराव पूर्ण कर लिया गया है। यह गतिविधियां पूर्ण सुरक्षा तथा गुणवत्ता के साथ ध्यान में रख के की जाती हैं।
Okay, now BIU in ALS mode. to ROD, range safety systems are ready.
Roger. T minus 21 minutes.
Start storage.
Vehicle director to TC director. All stack elements are ready to support GSLV-F14 INSAT-3DS mission launch.
TC director, Roger. Launch of criteria. GSLV-F14 launch vehicle.
GSLV-F14 कुल ऊंचाई 51.7 मीटर की होती है.
Telemetry can start storage. Number 503.
Storage started at VLCC.
काउंटडाउन के दौरान स्पेसक्राफ्ट को भी पावर ऑन किया जाता है तथा सभी संचार तंत्र, सेंसर्स, बैटरी जैसे अनेक तंत्रों की जांच की जाती है. इस दौरान एक सुरक्षा टीम भी यहां जांच के लिए जाती है लॉन्च पैड पर,
510 completed.
ताकि इसे पूर्णतः खाली कर दिया गया और यह पूरी तरह सुरक्षित है प्रमोशन के लिए.
ROD to mission director, range is ready for GSLV-F14 INSAT-3DS launch.
Mission director, Roger.
सभी तंत्रों की तैयारियों की सूचना अभी मिशन निदेशक को दी जा रही है. अभी हमने रेंज ऑपरेशन डायरेक्टर को देखा.
डायरेक्टर, रोजर.
Satellite director to mission director, INSAT-3DS spacecraft is ready for the launch of GSLV-F14 INSAT-3DS mission.
Mission director, roger.
Timing to control, timing confirms external hold mode.
Roger. VLCC and LCC2 to note. Timing confirmed external hold mode.
VLCC, roger.
LCC2, roger.
T minus 19 minutes.
सभी तंत्र जैसे यान, उपग्रह, रेंज ऑपरेशन तथा टेलीमेट्री ट्रैकिंग, इन सभी के निदेशक अपने तंत्रों की सूचना मिशन निदेशक को देते हैं. और अब
Mission readiness review and launch authorization board has already given clearance for proceeding with the countdown and launch of GSLV-F14 INSAT-3DS mission. All operations till the automatic launch sequence has been completed satisfactorily. Based on clearance obtained from vehicle, spacecraft, range and east-track stations and prevailing favorable weather conditions, Mission Director hereby authorized to initiate the launch operation sequence for the launch of GSLV-F14 INSAT-3DS mission at 17 hours 35 minutes IST today, that is 17th of February 2024.
All stations to note, Mission Director has given authorization for the launch of GSLV-F14 INSAT-3DS mission.
अभी आपने सुना मिशन निदेशक श्री टॉमी जोसेफ ने सभी तंत्रों की सूचना प्राप्त कर GSLV-F14 INSAT-3DS मिशन के ALS शुरू करने के लिए अनुमोदन दे दिया है.
Based on the confirmation that all the participating agencies are ready for the launch, you have watched the Mission Director Shri Tommy Joseph authorizing the launch. The ALS or the automatic launch sequence are a capsule of very essential verifications of the launch vehicle systems whose correct performance is imperative for a successful launch. Few minutes before the launch, the onboard computers will take over from the ground computers.
जी हाँ, ऑटोमेटिक लॉन्च सीक्वेंस शुरू हो चुका है तथा आंतरिक जांच जारी है. इसके पूर्ण होते ही यान के प्रथम चरण का प्रज्वलन शुरू हो जाएगा और इस दौरान सभी तरल ईंधन वाले इंजन्स की जांच होती है. ठोस नोदक के इग्निशन कमांड को आर्म कर दिया गया है. ऑनबोर्ड कंप्यूटर को फ्लाइट मोड में डाल दिया गया है. अंतिम कुछ मिनटों में प्रथम चरण के साथ L40 इग्निशन, क्रायो आर्म, लॉन्च होल्ड एंड रिलीज सिस्टम, इन सबको सक्षम कर दिया जाएगा. प्रमोशन में सर्वप्रथम हम देखेंगे T-4.8 सेकंड्स पर L40 जो कि तरल नोदक पर आधारित 4 स्टेप ऑन इंजन्स हैं, उनका प्रज्वलन शुरू होगा. L40 के प्रज्वलन शुरू होते ही इसमें पर्याप्त दबाव सुनिश्चित किया जाएगा और तभी लॉन्च होल्ड एंड रिलीज सिस्टम को मुक्त किया जाता है और GSLV F14 मुक्त होगा प्रमोशन के लिए, और उस समय T0 पर ही कोर बूस्टर S139 बूस्टर को प्रज्वलित किया जाएगा।
Launch operations of hydrogen tank commenced.
SDA servers activated.
ALSP Roger.
Data from SHAR-1 and SHAR-2.
Countdown for GSLV F14 INSAT-3DS mission commenced 27.5 hours before the scheduled launch time. During the countdown, the launch vehicle is powered on for checking
Automatic
the
launch
health.
sequence initiated for GSLV F14 launch.
It is about T-minus 15 minutes and confirmation is announced for the start of automatic launch sequence. During the countdown, the launch vehicle is powered on for checking the health of its various systems. The stage tanks are serviced with propellants. Gas bottles are charged and pressurized to their specified values.
T-minus 15 minutes.
Health of spacecraft is checked. Meanwhile, range tracking systems verify their functionality. About 5 hours ahead of launch, liquid hydrogen is serviced, and T-minus 2.5 hours, liquid hydrogen is serviced into the stage tanks.
मौसम पूरी तरह अनुकूल प्रमोशन के लिए, तापमान 30 डिग्री से कम, वायु गति भी पूरी तरह अनुकूल है। यहाँ विजिटर्स गैलरी में काफी मात्रा पर छात्र छात्रा यहाँ उपस्थित। अभी आप फिलिंग कंट्रोल सेंटर को देख रहे हैं।
T-minus 14 minutes.
इनसेट 3DS उपग्रह का कुल भार 2274 किलोग्राम है। इसे पृथ्वी की 170 किलोमीटर की उपभू तथा 37,682 किलोमीटर की अपभू कक्षा में 19 डिग्री के झुकाव के साथ स्थापित किया जाएगा। इनसेट 3DS भूस्थिर कक्षा में तीसरी पीढ़ी का मौसम विज्ञान का एक अनुवर्ती मिशन है। GSLV F14 इनसेट 3DS मिशन पृथ्वी विज्ञान मंत्रालय द्वारा पूर्णतः वित्त पोषित है। इसे मौसम पूर्वानुमान और आपदा चेतावनी के लिए भूमि और समुद्री सतहों के संवर्धित मौसम विज्ञान प्रेक्षण और निगरानी के लिए निर्मित किया गया है। यह उपग्रह वर्तमान में प्रचालनरत इनसेट 3D और इनसेट 3DR के साथ मौसम विज्ञान सेवाओं में वृद्धि करेगा।
As we wait for the launch, up next is the integration video for GSLV F14 INSAT-3DS mission. The integration of the rocket that took place in SDSC SHAR is brought to you.
अभी आप देख रहे हैं यह प्रथम चरण के कोर बूस्टर का नोजल एंड सेगमेंट सबसे निचला भाग है। इसे सावधानी पूर्वक मोबाइल लॉन्च पेडेस्टल पर रख दिया गया है और इसके ऊपर की ओर आ रहा है। यह मिडिल सेगमेंट है। यह प्रथम चरण का कोर बूस्टर कुल 5 भागों में बनाया जाता है। यह ठोस नोदक पर आधारित चरण है। यह तीसरा मिडिल सेगमेंट रख दिया गया और यह अंत में सबसे ऊपर की ओर हेड एंड सेगमेंट है। बड़ी सावधानी और गुणवत्ता सुरक्षा सभी को ध्यान में रखकर यह काम किया जाता है। यह इग्नाइटर है जो कोर बूस्टर को प्रज्वलित करता है। यह इंटर स्टेज प्रथम तथा द्वितीय चरण के बीच में जो इंटर स्टेज है इसे भी समायोजित कर दिया गया है। और यह आप देख रहे हैं L40 तरल नोदक पर आधारित स्ट्रैप-ऑन बूस्टर। यह भी कोर बूस्टर के साथ व्हीकल असेंबली बिल्डिंग पर लाकर सावधानी पूर्वक संयोजित कर दिया जा रहा है। इस तरह कुल 4 L40 स्टेजेस में लगेंगे। तरल नोदक पर आधारित यह L40, UH-25 तथा N2O4 को ईंधन के रूप में इस्तेमाल कर विकास इंजन का प्रयोग करता है और यह है द्वितीय चरण GS2 के नाम से हम जानते हैं।
Visuals from the vehicle assembly building that stands 18 stories tall. You have watched the integration of the first stage, the core stage, and the 4 liquid strap-ons. And this is the second stage called the GS2. And then the third stage, the cryo stage, which operates on liquid hydrogen and liquid oxygen, being prepared in its integration building and brought to the vehicle assembly building as a single unit for integrating with the launch vehicle. This is the equipment bay being hoisted very carefully and being placed on the cryo stage, upon which the satellite encapsulated assembly will sit. And these are the visuals from the clean room at the satellite preparation facility, the INSAT-3DS satellite getting ready to be assembled.
यह 3D INSAT 3DS उपग्रह है जो पूर्ण समायोजित होकर परीक्षित होकर यहाँ समायोजन के लिए लाया गया है। परीक्षण के पश्चात यहाँ इसे पेलोड एडेप्टर के ऊपर समायोजित कर ऊष्मा कवच के अंदर सुरक्षित कर दिया जाएगा।
That's the integration of the satellite with payload adapter, and then the closure of the two halves of heat shield or the payload fairing as it is called. It will now be moved from the satellite preparation facility to the vehicle assembly building.
यह ओजिव आकार का ऊष्मा कवच है जो कि वायुगतिक के दौरान स्थिरता बनाए रखता है।
The final movement of the rocket, all decked, all ready, towards the launch pad, where it will occupy few days for its preparation, waiting for the launch. Now this is the visual from the second launch pad, majestic view.
यह पूर्ण संयोजित GSLV-F14 लॉन्च व्हीकल दृढ़ता से लॉन्च पैड पर खड़ा हुआ, अपने अंतिम जांचों के पश्चात प्रमोशन के लिए तैयार और अपने मिशन के लिए तैयार। सभी यहाँ उत्सुक प्रमोशन को देखने के लिए।
T-8 minutes.
For the GSLV launch, there are two major launch critical ground systems at the launch pad. The re-engageable launch hold and release system, RELHRS, ensures that the launch vehicle is held on the pedestal against disturbing forces during the strap-on engine startup and thrust buildup. And the pair of cryo arms which support the heavy vacuum insulated hoses for the servicing of LOX and LH2 from umbilical tower to the launch vehicle. This one separates and swings out milliseconds after liftoff sensing.
इस प्रमोशन का घटनाक्रम कुछ इस प्रकार है। यहाँ उल्टी गिनती करते हुए T-4.8 सेकेंड्स पर तरल नोदक वाले 4 L40 स्ट्रैप-ऑन का प्रज्वलन शुरू होगा। उचित दाब की प्राप्ति होने पर LHRS लॉन्च होल्ड एंड रिलीज सिस्टम
T-7 minutes
को मुक्त कर दिया जाएगा और तभी T0 पर कोर बूस्टर S139 का प्रज्वलन शुरू होगा। इस समय प्रमोशन यान का प्रमोशन होगा और प्रमोशन मंच से उत्थापित होगा। प्रथम चरण लगभग 110 सेकंड तक प्रज्वलित रहकर यान को 40 किलोमीटर की ऊंचाई प्रदान करेगा, लेकिन L40 स्टेज 148 सेकंड तक प्रज्वलित रहेंगे। अब यान की ऊंचाई 70 किलोमीटर की होगी, तब प्रथम चरण को यान से पृथक कर दिया जाएगा। इस यान में द्वितीय चरण का प्रज्वलन पहले शुरू हो गया और पृथक के तुरंत बाद ही द्वितीय चरण का प्रज्वलन शुरू हो जाता है। इसे हम हॉट सेपरेशन कहते हैं। अब यान 70 किलोमीटर की ऊंचाई पर 2.28 किलोमीटर प्रति सेकंड के वेग के साथ अपने यात्रा जारी रखेगा
Vehicle on internal
और
power.
द्वितीय चरण का प्रज्वलन के 24 सेकंड के पश्चात 110 किलोमीटर की ऊंचाई प्राप्त कर लेने पर
6 minutes.
यान से ऊष्मा कवच को पृथक कर दिया जाएगा। द्वितीय चरण अपना कार्यकाल 141 सेकंड का पूरा कर यान को 130 किलोमीटर की ऊंचाई पर ले जाएगा तथा यहां पर सापेक्ष गति होगी 4.76 किलोमीटर प्रति सेकंड। तत्पश्चात GS2 यानी द्वितीय चरण को यान से पृथक कर दिया जाएगा। यह पूरा काम ऑन बोर्ड कंप्यूटर द्वारा संपन्न किया जाता है। द्वितीय चरण के अलग होने के 1 सेकंड पश्चात ही सबसे जटिल इंजन वाले क्रायो इंजन का प्रज्वलन शुरू कर दिया जाएगा। यह तरल ऑक्सीजन और तरल हाइड्रोजन पर आधारित क्रायो चरण है। यह वह अंतिम चरण है जो INSAT-3DS उपग्रह को करीबन 827 सेकंड प्रज्वलित रहकर उद्दिष्ट कक्षा में स्थापित करेगा।
We are 5 minutes away from the launch, and while we wait for the launch to take place, let me appraise the viewers regarding the burn-in staging events expected to take place for the nominal flight of GSLV-F14 INSAT-3DS mission.
Performance is normal.
The 4 strap-on stages, the L40s, will ignite first, and 4.8 seconds later, after ensuring their full thrust, the core S139 ignites. Ignition of S139 coincides with the T0 or liftoff. All the 5 engines develop thrust simultaneously. At 110 seconds into flight and 40 kilometers altitude, S139 burns out and L40 stages continue to develop power till 148 seconds. Though the first stage completes its operation, the staging of first stage is typical hot separation, wherein the second stage, GS2, ignites before the separation of GS1. By now, the rocket is at 70 kilometers altitude.
T-minus 4 minutes.
The burn time of GS2 is 141.4 seconds. By the time the stage completes operation, an altitude of 130 kilometers would have been achieved. During the operational regime, the rocket clears the dense atmosphere and hence 2 major flight events take place. Initiation of closed-loop guidance and separation of payload fairing. 3 seconds after GS completes its operation, it is separated from the ongoing rocket. The cryogenic upper stage is commanded for ignition 1 second thereafter. This third stage of GSLV is powered by indigenous engine and stage C15. The burn time of third stage is 113 seconds. While only 100 kilometers is added in terms of altitude, the relative velocity addition is remarkable, 5 kilometers per second.
T-minus 3 minutes.
For the viewers to better appreciate this change in velocity, let me tell, when cryo stage begins, the relative velocity is 16,920 kilometers per hour. And by the time it ends its operation, it is 34,920 kilometers per hour. This high velocity is characteristic of geosynchronous transfer orbit. The spacecraft of the mission INSAT-3DS is scheduled to be injected at 1123 seconds into flight, or as close as possible to this time mark when the right orbital parameters are achieved. This is the periapsis of the orbit. Once the spacecraft reaches the apoapsis of this high eccentricity orbit, it performs a burn using spacecraft propulsion to circularize its orbit.
अब हम प्रमोचन से 2 मिनट की दूरी पर
T-minus 2 minutes.
Excitement for the launch building up. We are very close to the launch, about 90 to 100 seconds away.
सभी छात्रगण बड़े उत्साहित होकर इंतजार करते हुए प्रमोशन का भारी संख्या में यहां उपस्थित हैं। मौसम पूरी तरह अनुकूल, शाम का समय है। ये सारी गतिविधियां सुचारू रूप से जारी हैं।
Oxygen tank ready.
सर्वप्रथम हम ध्यान देंगे L40 का इग्निशन शुरू होगा
All stations
और कोर
stand by for
बूस्टर
the
के
time mark.
प्रज्वलन के तुरंत पश्चात क्रायो आर्म को
T-1 minute.
अलग रिट्रैक्ट कर दिया जाएगा.
All stop sound.
Minus 55 seconds.
L40 VHPP opened.
Minus 50 seconds.
Gas bottle ready.
Minus 45 seconds.
All sequencers armed.
Hydrogen tank ready. Cryo stage ready.
Minus 40 seconds.
GS2 VHPP opened.
Minus 35 seconds. Minus 30 seconds.
L40 VSPP opened.
Real-time programs activated.
Minus 25 seconds.
GS2 VSPP opened.
GS1 ignition.
Minus 20 seconds. Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1,
L40 stages
0.
are ignited.
Plus 5 seconds.
Liftoff normal.
A perfect liftoff. GSLV-F14
Plus 10
INSAT-3DS progressing towards its
Stage
destination.
performance normal.
Plus
जी हाँ,
15
अभी हमने
seconds.
देखा चारों L40 तथा कोर बूस्टर का प्रज्वलन शुरू हो
Plus
चुका
20
है
seconds.
और GSLV F14 उत्थापित हो अपने उद्दिष्ट दिशा की ओर बढ़ता हुआ.
Clear sky. We can see the rocket, very beautiful. And from the mission control center here, we can hear the vibrato also.
शाम का समय, बहुत दूर तक हम यान को देख पा रहे हैं. इसका सामान्य प्रज्वलन, इसका कंपन भी हमें यहां महसूस होता
Char 1
है.
is in main auto.
यान अपनी उद्दिष्ट कक्षा की ओर बढ़ता हुआ.
Char 2 is in main auto.
Plus 1 minute.
प्रथम चरण के कोर बूस्टर का प्रज्वलन काल 110 सेकंड के करीब होता है और इस दौरान यह 8400 किलो न्यूटन का प्रणोद उत्पन्न कर रहा है.
First stage performance normal.
प्रथम चरण में कोर बूस्टर तथा 4 L40 स्ट्रैप-ऑन बूस्टर सामान्य निष्पादन करते हुए.
P2 change over to
Presently, the core booster and the 4 L40 strap-ons thrusting simultaneously. S139 scheduled to burn for 110 seconds.
S139 stage ban out.
एनिमेटेड व्यू में आप देख पा रहे हैं 4 L40 तथा कोर बूस्टर
Plus 2
S139
minutes.
प्रज्वलित है.
First stage performance normal.
कोर बूस्टर अब बर्नआउट हो चुका है, उसका प्रज्वलन काल समाप्त हो चुका है, लेकिन L40s अभी भी जारी हैं. इन्हें 148 सेकंड पर बंद कर यान से पृथक कर दिया जाएगा.
The 4 L40s thrusting presently. The launch vehicle is being tracked by the tracking station at Shar.
40 stages thrust cut off. First stage separated. Second stage ignited.
रेंज ऑपरेशन निदेशक ने अभी इसकी पुष्टि की. प्रथम चरण को यान से सफलतापूर्वक पृथक कर दिया गया है
Guidance initiated.
और उसके तुरंत बाद ही GS2 द्वितीय चरण का प्रज्वलन भी शुरू हो चुका है.
Second stage performance normal.
There are a quick succession of several flight event confirmations by the Range Operations Director.
Plus 3
The
minutes.
first stage comprising of the S139 and L40s have been separated. The second stage is ignited and the performance is reported to be normal. We are 190 seconds past the launch time. Present altitude is close to 100 kilometers and closed loop guidance has been initiated.
वर्तमान में द्वितीय चरण GSLV F14 का प्रज्वलनरत है.
Second stage performance normal.
इस दौरान यह 846 किलो न्यूटन का प्रणोद उत्पन्न कर यान को उद्दिष्ट कक्षा की ओर ले जा रहा है. इसमें विकास इंजन का उपयोग किया जा रहा है और इसमें इंजन जिबल
Payload fairing separated.
यान से ऊष्मा कवच को पृथक कर दिया गया है। अब यान की ऊंचाई 113 किलोमीटर है। यह घने वातावरण को पार कर चुका है।
4 minutes.
Dense atmosphere has been crossed by the launch vehicle and hence the payload fairing has been separated. Presently, Shah ground station continues to track and Port Blair station has started to acquire the data.
यह मिशन पूर्वी दिशा का मिशन है, इसलिए शार स्थित पोर्ट ब्लेयर स्थित ग्राउंड स्टेशन वर्तमान में इसे ट्रैक करते हुए
The planned burn time of GS2 is 141.4 seconds.
क्रायो अपर स्टेज जो कि तृतीय चरण है GSLV-F14 का, उसे ऑथराइज कर दिया गया है प्रज्वलन के लिए। द्वितीय चरण के प्रज्वलन काल के पश्चात पृथक्कन होगा।
Stage thrust cut off. Stage ignition commanded.
द्वितीय चरण के प्रज्वलन काल के पश्चात उसे यान से पृथक कर दिया गया है।
Stage ignition confirmed.
Now a jubilant atmosphere here in the mission control center as the confirmation of the CUS engine startup has been obtained.
जी हाँ, सभी वैज्ञानिक यहाँ उत्साहपूर्वक इंतजार करते हैं सबसे जटिल इंजन क्रायो इंजन का प्रज्वलन, जिसकी पुष्टि हो चुकी है, वह प्रज्वलित हो चुका है और सामान्य निष्पादन करते हुए उद्दिष्ट कक्षा की ओर बढ़ रहा है। क्रायो इंजन लिक्विड ऑक्सीजन तथा लिक्विड हाइड्रोजन को ईंधन के रूप में इस्तेमाल कर 75 किलो न्यूटन का प्रणोद उत्पन्न करेगा और इसका कुल प्रज्वलन काल 814 सेकेंड।
Burn time for cryogenic upper stage is 814 seconds.
सभी दर्शकों के लिए यह उत्साहपूर्ण पल।
Cryo stage performance normal.
Present relative velocity is close to 5 kilometers per hour. The cryo stage, I'm sorry, the relative velocity presently is 5 kilometers per second.
सभी वैज्ञानिक अपने कंसोल पर आंकड़ों का अध्ययन करते हुए इस मिशन के मुख्य उद्देश्य इस प्रकार हैं। INSAT-3DS पृथ्वी के सतह की निगरानी करने के लिए मौसम विज्ञान के महत्व के विभिन्न वर्णक्रमीय चैनलों में समुद्र और उसके पर्यावरण का प्रेक्षण करना, वायुमंडल के विभिन्न मौसम संबंधी मापदंडों की ऊर्ध्वाधर रूपरेखा तैयार करना, डेटा संग्रह तथा डेटा प्रसारण की क्षमता को बढ़ाना, उपग्रह की सहायता से खोज एवं बचाव सेवाएं प्रदान करना। यह सभी उद्देश्यों के साथ INSAT-3DS यात्रारत है अपने उद्दिष्ट कक्षा की ओर।
+8 minutes.
The satellite INSAT-3DS is fully funded by the Ministry of Earth Sciences, various of its departments such as India Meteorology Department, IMD, National Centre for Medium Range Weather Forecasting, NCM-RWF, Indian Institute of Tropical Meteorology, IITM, National Institute of Ocean Technology, NIOT, and Indian National Centre for Ocean Information Services, INCOIS, and various other agencies and institutes will be using INSAT-3DS satellite data to provide improved weather forecasts and meteorological services.
INSAT-3DS उपग्रह को पूर्णतः इसरो के मानकानुसार तैयार किया गया है।
Cryo stage performance
इस उपग्रह
normal.
का अक्ष नियंत्रण शून्य संवेग अभिनति तंत्र पर निर्धारित है, जो 4 रिएक्शन व्हील्स तथा जायरो की मदद से क्लोज लूप नियंत्रण का प्रयोग करेगा। इसमें ऊर्जा तंत्र में 100 एम्पियर आवर लिथियम आयन बैटरी के साथ एक तरफा सौर पैनल का प्रयोग किया जा रहा है, जो लगभग 1.6 किलोवाट की ऊर्जा उत्पन्न करेंगे। इसमें सक्रिय तथा निष्क्रिय ताप नियंत्रण का इस्तेमाल किया जा रहा है। इस उपग्रह को 10 साल के मिशन काल के लिए अभिकल्पित किया गया है। INSAT-3DS के निदभार में 6 चैनल इमेजर है, 19 चैनल साउंडर, डेटा रिले ट्रांसपॉन्डर और उपग्रह सहाय खोज एवं बचाव के लिए ट्रांसपॉन्डर्स लगे हुए हैं। इन सभी निदभारों के द्वारा INSAT-3DS मौसम संबंधी क्रांतिक आंकड़ों को इकट्ठा करने में सक्षम होगा।
+10 मिनट।
मौसम संबंधी सभी आंकड़ों को पृथ्वी विज्ञान मंत्रालय के अंतर्गत विभिन्न विभाग जैसे भारतीय मौसम विज्ञान विभाग, राष्ट्रीय मध्यम अवधि मौसम पूर्वानुमान केंद्र और ऐसे कई प्रौद्योगिकी एवं अनुसंधान संस्थानों के साथ इसे साझा कर इस उपग्रह को अधिक से अधिक उपयोग में लाया जाएगा। इन सभी आंकड़ों से मौसम पूर्वानुमान और संवर्धित होगा और सटीक हो सकेगा। वर्तमान में क्रायो अपर स्टेज प्रज्वलित है और समान निष्पादन कर रहा है। अब यान की ऊंचाई 136 किलोमीटर तथा सापेक्ष गति 6.1 किलोमीटर प्रति सेकंड है।
We are close to 11 minutes past the launch time. Port Blair station currently tracking, and Brunei station will shortly start to acquire the data. INSAT-3DS satellite carries a multispectral imager or optical radiometer capable of generating images of Earth and its environment in 6 wavelength bands. Atmospheric motion vectors are derived by tracking clouds or water vapor pattern in successive satellite images. AMV includes information on wind speed and direction. The 19-channel sounder payload will provide the information on the vertical profiles of the atmosphere, sea and land surface temperature, cloud properties, and microphysical parameters, upper tropospheric humidity, humidity profiles,
+12 minutes,
and total ozone, etc. to study about atmosphere, land, and ocean. Data relay transponder receives global meteorological, hydrological, and oceanographic data from automatic data collection platforms or automatic weather stations from multiple users and relays back to user terminal. The data products that generated cater to varied range of applications. The history of automatic weather stations in India can be traced back to 1980 when IMD conducted a pilot experiment with ISRO to operate small network of data collection platforms via satellite for Earth observation to the receiving station at Sriharikota.
Cryo stage performance
In
normal.
1997, the AWS network was upgraded. IMD has a network of many AWS, Agro AWS, and ARC.
इस उपग्रह में मुख्य नितभार के रूप में है इमेजर पेलोड। INSAT-3DS उपग्रह का यह नितभार एक मल्टी स्पेक्ट्रल इमेजर है जो पृथ्वी और उसके पर्यावरण की 6 तरंग वेवलेंथ में प्रतिबिंब लेने में सक्षम होगा। इस उपग्रह में 19 ट्रांसपॉन्डर पेलोड भी हैं। साउंडर पृथ्वी के वायुमंडल की लंबवत रूपरेखा तैयार करेगा और इसमें सम्मिलित हैं तापमान, आर्द्रता आदि सम्मिलित हैं। इसमें डेटा रिले ट्रांसपॉन्डर लगे हुए हैं जो स्वचालित डेटा संग्रह प्लेटफॉर्म में वैश्विक स्तर पर मौसम, जल तथा समुद्र विज्ञान के आंकड़ों को इकट्ठा कर एक जगह से दूसरी जगह रिले करने में सक्षम होंगे। इस उपग्रह में खोज और बचाव कार्य के लिए ट्रांसपॉन्डर लगे हुए हैं। इसमें बीकन ट्रांसमीटर हैं जो आपदा संदेशों को रिले करता है और चेतावनी संदेशों के लिए भी संवेदनशील है। UHF बैंड में वैश्विक कवरेज के साथ यह आपदा प्रबंधन में एक बहुमूल्य सहायक होगा।
Cryo stage performance normal.
We are 14 minutes, close to 30 seconds past the launch time. Cryo stage presently operational and developing nominal thrust. Brunei station continues to track.
यह मिशन पूर्वी दिशा का मिशन है, इसलिए ग्राउंड स्टेशन शार 1, शार 2 तथा पोर्ट ब्लेयर, ब्रूने, बैग स्थित ग्राउंड स्टेशंस हमें इसके आंकड़े उपलब्ध करा रहे हैं।
INSAT-3DS satellite is configured around ISRO's well-proven I2K bus platform. Satellite bus is the main body and structural component of a satellite in which the payload and all scientific instruments are held. A bus typically consists of the following subsystems: command and data handling system, communication system and antennas, electrical power system, propulsion thermal control, attitude control system, navigation guidance and control, structures and trusses. INSAT-3DS weighs 2,274 kilograms, hence the selection I2K bus.
क्रायो पर स्टेज तृतीय चरण और अंतिम चरण है GSLV-F14 का। वर्तमान में यान की ऊंचाई 153 किलोमीटर तथा सापेक्ष गति 8.3 किलोमीटर प्रति सेकंड है। सभी तंत्र क्रायो इंजन के सामान्य निष्पादन करते हुए इस दौरान यह 75 किलोन्यूटन का प्रणोद उत्पन्न कर उपग्रह को उद्दिष्ट कक्षा में ले जाता है। इसमें अभिवृत्ति नियंत्रण के लिए 2 वर्नियर जेट्स लगे होते हैं। यान पूर्णतः टेक्स्ट बुक लॉन्च प्रदर्शित करता हुआ जैसा अनुमानित था, अनुमानित पथ के ऊपर में ही जाता हुआ GSLV-F14
plus 17 minutes.
यह ये भी दर्शाता है कि हमारी गणना और सभी कार्य सुनिश्चित सुनियोजित तरीके से पूरी हुई हैं और गुणवत्ता का खास ध्यान रखा गया है।
Objective of the present launch is to place the weather observation satellite INSAT-3DS in geosynchronous transfer orbit, whose perigee is 170 kilometers and apogee is 37,682 kilometers.
Cryo stage performance normal.
The relative velocity acquired presently is 9.28 kilometers per second.
अब कुछ ही सेकंड्स में हम देखेंगे तृतीय चरण के कार्यकाल को समाप्त कर इसे बंद कर दिया जाएगा और अंतःक्षेपण उपग्रह के अंतःक्षेपण की स्थितियां प्राप्त होते ही उपग्रह को तृतीय चरण से पृथक कर उसकी उद्दिष्ट कक्षा में अंतःक्षेपित किया जाएगा। टेलीमेट्री द्वारा डेटा में
Satellite injection conditions are achieved.
क्रायो चरण को बंद कर दिया गया है। सुनियोजित ढंग से यह किया जा रहा है, यह पूर्व निर्धारित है।
INSAT-3DS satellite separated. GSLV-F14 INSAT-3DS mission accomplished. Handing over to mission director.
जी हाँ, सभी दर्शकों को शुभकामनाएं। यहाँ INSAT-3DS उपग्रह को अंतक्षेपित कर दिया गया है।
And we have a successful mission of GSLV-F14 INSAT-3DS. Hearty congratulations to Team ISRO and users from the Ministry of Earth Sciences. Do continue to stay tuned for the address by Secretary, Department of Space and Chairman ISRO, Shri S. Somnath.
हम अब आपको ले चलते हैं चेयरमैन इसरो के भाषण के लिए।
Okay.
I'm very happy to announce the successful accomplishment of the mission GSLV-F14 INSAT-3DS. The spacecraft has been injected into a very good orbit. The injection conditions were as expected, and we also noted that the vehicle has performed very, very well. And congratulations to everybody who has been part of this mission, the team that built the INSAT-3DS for the Ministry of Earth Science from the satellite centers, and also the launch vehicle teams who built the GSLV-F14 for this mission. My greetings and congratulations to everybody for this accomplishment. And INSAT-3DS is the next generation weather satellite with improved capability over the existing INSAT series, which is there in orbit, INSAT-3D and INSAT-3DR. And this will augment the capability of observation of various atmospheric parameters that leads to the information related to the weather and the climate. And also it gives a lot of data in terms of the data collection platform as well as distress satellite terminal related operations as well. So let me congratulate the team who built the payloads, the satellite, and also the launch vehicle for this excellent mission this year. Let me hand over to the mission director, Sri Tommy Joseph.
Thank you, sir. Respected Chairman ISRO, Senate Heads, all the gurus, and all the colleagues from all ISRO centers. So the naughty boy has now become and matured as a very obedient and disciplined boy. And so like PSLV, GSLV has also become a very robust vehicle for ISRO. So I congratulate and salute all the ISRO family members on this occasion. So GSLV-F14 vehicle, after the majestic liftoff, it has injected INSAT-3DS or satellite into the precise injected orbit. So this is the 10th mission of GSLV with the cryogenic indigenous stage actually. So in this mission, compared to the previous mission, around 50 kg payload he was increased actually. So this mission is possible only by the hard and dedicated work of all the ISRO employees. So I thank Chairman ISRO, all the secretaries for their consistent and continuous guidance, support and encouragement. And I also thank Chairman, alternate Chairman MRR, Chairman Lab, Chairman FRLV, alternate Chairman, and all the review forums for the excellent review, comprehensive review. And also I thank all the SDAs, System Development Agencies, and the reliable SR agencies all over the ISRO centers, across all the centers, for the excellent delivery of all the timely delivery of all the subsystems and vehicle systems, and also the SR agencies for the critical quality assessment. And I also thank the industrial partners who have delivered very high reliable vehicle systems. I compliment our family members, very loving family members, who have supported indirectly for this mission. I also thank the all National Eminent Committee experts who have given us very valuable guidance, and all the gurus and pioneers here. I am extremely happy to thank actually the project executives, mission executives, and the vehicle team led by Vehicle Director Karthikeyan and Associate Vehicle Director Gladwin, and also for their excellent teamwork. And also I thank the satellite team led by Imtiaz Ahmed, and I wish all these subsequent operations also very success. I am extremely grateful to Chairman ISRO and the higher management for giving me this opportunity, and also the responsibility of leading this project. We are eagerly looking for the next prestigious GSLV mission, an international collaboration with the NASA for the NISR launch. I wish all the very success for all the future endeavors and missions of ISRO. Once again, I thank each and everyone, and also the Almighty, for this magnificent mission. Thank you. Jai Hind.
We are also very happy to announce the deployment of the solar panel of the satellite. And before we move further, I request the Spacecraft Director, Sri Imtiaz Ahmed, for his words.
मंजिलें क्या है, रास्ता क्या है, हौसला हो तो फासला क्या है. Respected Chairman ISRO, Center Directors, my senior colleagues, and all fellow ISROites, very good evening to all of you. First of all, my hearty congratulations to all ISRO team members and the family members for a marvelous launch. In fact, firstly I should thank GSLV team for precise injection orbit and the 4-meter payload fairing, as well as the maximized lift-off mass. In fact, we could not have asked better than this, perhaps. In fact, the 4-meter payload fairing is extremely important for the satellite community, as it provides larger flexibility for building larger spacecrafts. In fact, INSAT-3DS is a live example where a lot of improvement could be achieved due to the larger fairing. Now, INSAT-3DS is essentially a third-generation meteorological satellite built around I2K platform with imager, sounder, DRT, and SAR payloads. The payload systems are designed for monitoring land, ocean, its environment, as well as the vertical profiling of the atmosphere for the weather forecasting and the disaster warning systems. Now, also, the payload includes data collection and dissemination capability, as well as satellite-added search and rescue services with the global receive coverages. Now, while INSAT-3DS will provide continuity of services for INSAT-3D and 3DR, the payloads of INSAT-3DS has been significantly enhanced, as Chairman Sir has already told, and the enhancement is in terms of configuration, content, and capability, resulting into improved radiometric accuracies, black body calibration, and the increased imaging throughput. Now, already INSAT-3DS is on its way to the destination. Chairman Sir mentioned that the solar panel is already deployed. A series of orbit testing maneuvers will be performed over next few days, followed by in-orbit testing and the commissioning of the spacecraft. On this joyous occasion, I would like to thank Chairman ISRO, Center Directors, my senior colleagues, and review forums for their unstinting support throughout. The celebration will only be meaningful and complete with my team members engineers, technicians, and administrative staffs who toiled hard to make this wonderful satellite. Before I end, I wish to acknowledge the personal sacrifices made by the team members and their families which made today's triumph possible. I am sure this satellite will be another colorful feather in India's meteorological satellite constellation, saving the life of millions and properties worth billions. Thank you all. Jai Hind.
With this mission, our confidence on the GSLV is further high, and as all of you know, that the next mission of the GSLV is going to be the NASA ISRO synthetic aperture radar satellite, which is scheduled, and this gives us greater confidence on this mission to take on with the accomplishment of the NISAR launch soon. But before we end, I would like to request the Center Directors to have their quick feedback and response to this mission. First, let me invite the Director of VSS.
Good evening. So we had a very successful GSLV mission, though it is called as a naughty boy, but you have seen that though it has become smarty, still the name carries. Sometimes, children, they are naughty, the name will be there, but it has become very smarty and naughty, but still it is called naughty. But I'm sure the reliability of the vehicle is high. It is now just demonstrated is with 4-meter firing, and it is as reliable as any other vehicle. The campaign also was very smooth, and the 27 plus count time also even less. Everything was very smooth, and I would take this opportunity to thank the entire launch vehicle centers, especially VSSC, LPSC, IASU, SHAR, and STRAC, and SDSC. Of course, wishing all the very best to the satellite team for further smooth ride. Thank you.
Good evening to all of you. Today, we in ISRO have made yet another major accomplishment. The 16th GSLV vehicle, the GSLV-F14, equipped with 10th indigenous cryogenic stage, has placed the INSAT-3DS spacecraft in the required orbit. All the vehicle systems, which include S-139 solid motor, 5 air-storable propulsion stages, cryogenic upper stage, and all the vehicle systems have performed as expected and as predicted. From the first GSLV D1 flight, which lifted off 1,526 kg satellite, we have gradually improved the performance of the vehicle in an innovative and smart way, and the payload today is 50% increased, and we have placed the 2,274 kg satellite in the required orbit. This vehicle also had large number of control components, fluid control components, something around 444 fluid control components and modules. Everything has performed as expected. Today's achievement once again demonstrate the team and smart work of ISRO and our robust and open review system and the superior techno-managerial leadership. I am sure the spacecraft built for the MOS will serve its intended function and serve our nation in the coming years. On this occasion, I am extremely happy about the performance of the systems and congratulate all the ISRO team members, our family members, the industrial partners, and thank all our elders. Thank you. Jai Hind.
Good evening. As with age, a wine matures. The INSAT-3DS spacecraft as well as the GSLV launch vehicle seem to have matured. Now the launch vehicle has given an textbook-like performance with additional 2.8 thousand kilometers extra altitude, which will mean ultimately another 3 months life for the spacecraft. The spacecraft also, which was started during the 2016-17 time frame for realization as a ground spare for the INSAT-3DR spacecraft, has now been tended to by the project team for over the past 6-7 years to make it ready for launch now. And this period has been well utilized by both the spacecraft team as well as the payload team, so that the whatever minor observations were there in orbit in INSAT 3D and 3DR have been accounted for and corrected, verified, and now we have this spacecraft moving towards its final destination. And I'm seeing that the first commands also have been sent to the spacecraft, and the spacecraft is responding. So we are looking forward to extended life for this INSAT 3DS spacecraft to meet the requirements of our MOE's ministry as well as the IMD's capabilities of weather forecasting is going to get some additional strength through this data that is going to be provided by this. I also take this opportunity to thank our launch vehicle friends for making this INSAT 3DS launch by GSLV-F14 meticulous one. Thank you very much, and Jai Hind.
Good evening and congratulations to all of you. So just like our last mission, this mission also has become quite a marvelous success, and the injection accuracies that we have achieved are also comparable to last F12 mission. At this occasion, let me congratulate the entire team, entire ISRO team, also my IAC team specifically, who has provided this navigation system, which is our legacy navigation system called Resins 4, which is flying on its 31st mission now. And we are very proud of its performance. So congratulations to all of you, the ISRO team, the industries, and the nation that supports us always. Thank you. Thank you all.
Congratulations, India. It has been a very wonderful experience to build this vehicle, to build the stages for all these vehicles, and to see the successful performance of this vehicle on this day, taking the satellite to the destined orbit. And at this point of time, I thank the IPRC community for bringing the 4 engines successfully for the L40 stages, the GS2 stage and the CUS stage, the host of testing of all the spacecraft propulsion systems, and supplying the quality liquid hydrogen for the launch. I also wish the spacecraft team to take further to the geostationary orbit and do all the operations successfully for the years to come. Jai Hind.
Good evening. It's heartening to note that we had a marvelous launch, and all the stations down the range have tracked perfectly from Brunei, Biak, as well as Port Blair. All the teams have really done excellent review and ensured that there is no stone left unturned. I would like to congratulate the project, the satellite team, and we have many more operations to go, and our ISRAC stations are going to support for raising the orbit to geosynchronous orbit. Thank you one and all, and congratulations once again. Jai Hind.
As is customary, the last word is always from the host center, Satish Dhawan Space Centre, Director of the Satish Dhawan Space Centre, who is the Chairman of the Launch Authorization Board, will speak now.
Thank you, sir. Respected Chairman, mentors, all ISRO colleagues, and all those witnessing a very important mission, the weather and climate satellite, one of the heaviest one, launched by GSLV-F14. As we recall, all the engines and every preparation of the stage was prepared well in advance, and the launch campaign was actually very smooth. And as all the solid motors, segments, everything went without any hitch, no issue, and it's one of the most cleanest launch campaign that we have witnessed in the recent times, without any hiccups and smooth. And it goes for the professionalism that we have shown here, that we had the both final MRR, clearance and lab well in advance of 2 days of the launch. That speaks the confidence level that this launch vehicle has been achieved. And also kudos to the entire team and also the ground segments team at SHAR as well as all over the centers to have done such an excellent job. Keep it up. We are also, whatever is expected of this vehicle for this campaign has been achieved, and there is a lot of enthusiasm in keeping this going, and we are also getting ready for the next launch as Project Director was putting. So, once again, excellent work, teamwork, achieving this, expecting the next launch campaign to start soon, expecting to see you all in the next launch campaign. Thank you. Thank you very much. And Jai Hind.
Thank you once again. Goodbye from Satish Dhawan Space Centre, and we meet for the next launch process from Satish Dhawan Space Centre. Good evening and bye. Thank you so much.
Fellow space enthusiasts, the GSLV-F14 INSAT-3DS mission showcases human ingenuity in our quest to explore the cosmos. From the thunderous liftoff to the intricate details of GSLV-F14 and INSAT-3DS, this journey has been extraordinary. Let's appreciate the collaborative efforts of scientists and engineers who make these space odysseys possible. GSLV-F14 symbolizes human innovation, propelling us towards new frontiers. Thank you for joining us. Your curiosity fuels our passion for space exploration. If you enjoyed this video, like, share and subscribe for more exciting content. We want to hear from you. Drop your suggestions for future space missions or topics in the comments. Your feedback is invaluable. As we wrap up, remember, the cosmos is vast and there's always more to explore. Until our next adventure, keep looking up, stay curious, and embrace the wonders of the universe. This is Paul Meshi, your host, signing off. Safe travels among the stars.